you. So welcome back. And this is a combined panel, very informal. The whole idea here is to bring the supply side, the demand side, and NASA folks together, and let's ask questions, and you can ask questions to each other if possible. Okay. So let me start off. I see this interesting question from Paul Blaise in the Q&A. And let me pose this question to Mark Hilburger and Jerry Sanders, if I may. Could NASA run a materials fabrication contract similar to a CLIPS mission where it asks for bids on, say, 1 kg of water or aluminum for an upcoming lunar mission? So if you think you can answer this question, please go ahead. Mark, Jerry?
I'll give it a first shot. So, I mean, funding a mission where you just asked for a certain amount of product is possible. That is one way of going forward. If you look at our current strategy, though, we are aiming more towards enabling companies to take the lead, and multiple companies for that matter, to take the lead on developing their technologies, having NASA enable what they're doing either through contracts or through, different types of support systems. So until we have a clear user for the products, at this point, I think it's a better approach to kind of push all the technology, companies forward to a certain extent versus just arbitrarily stating, I want 1 kilogram of water, at a certain location. That's, I think, at this point would be more helpful. But that, again, these, as Mark McDonald said, our plans are going to go out for comment, and so we welcome all the comments that the community will bring forward.
Yeah, I'll probably say the same thing, but just a little bit differently from what Jerry said. Our strategy right now, and I'm excited to, I'll just step back and say I'm excited to have our packages come out, because I think a lot of the questions and needs that were just brought up today, you'll see reflected in our thinking as well. And the strategy that many of us are taking, Jerry included, is developing these partnerships with industry so that we can develop a commercial capability on the moon, and then NASA will be one of the customers of those capabilities. And so if we need water, then we'll say, hey, all right, that system that we helped you develop, but we want to buy some water from it. Same goes for construction materials or construction equipment, that sort of thing. So we want to be able to help you develop the capabilities and then be one of the potential buyers of those commercial services.
Thank you, Jerry. Thank you, Mark. Karl?
Yeah, I just want to add one more item.
Yeah.
And I think this workshop is a great example of the chicken and the egg situation, just like we had with our supply demand for propellants and the transportation architecture. Here again, we had good presentations on both what the companies think they can make, as well as, manufacturers and what kind of things they want. So instead of arbitrarily NASA saying, I want water of a certain quality or quantity, it's actually better for the community as a whole to kind of work both ends of this story. And this is the first step. But so if NASA said, I want, a kilogram ingot of aluminum, is there actually a user for that? At this point, we have really good conversations along those lines. So here again, I think just specifying something like that at this point is probably not, again, the best.
Jerry, I think again you hit the nail on the head, and you kind of led into the question that I wanted to ask, which is really a permutation of what Laurent asked for the second time, the first time this question was dismissed because we ran out of time to address it, but not because we didn't like it, because we ran out of time to address it. And it's written here. I'll modify it slightly. His point is, and I think this question is to the providers of the materials and to industry, basically, which is, to what extent does sustained presence need to be defined? You know, because from the presentation we've heard before, it seems like information is what is needed for industry to really decide what it needs to do. And good enough needs to be defined, because we don't have the money or time to do things perfectly. We only barely have enough time to do it good enough to accomplish our goals. So the question that Laurent is asking, you guys can read it, and I paraphrase it, is, to what extent does a sustained presence need to be defined? One location, multiple locations, and what will they require as a minimum infrastructure? What is good enough in terms of a sustained presence? And related to that, then, and this is for anybody in industry to answer, how would you go about building that? So the question is asked, this would establish a first set of high-level requirements and a description of interfaces between surface systems. This would also give industry information on what needs to be done. And maybe that's more important than a requirement, because requirements can lead you to telling you how to do something, whereas in reality, what you need to know is what to do and what are your constraints in doing them. So I would like industry to talk about what do they see that they need in terms of information from NASA, or about the moon, or about what NASA needs to do, or from each other, like supply side to demand side and back and forth. What do they need from each other so that they each can go forward? So I know this is hugely open-ended, but I think Laurent hit upon a really important question there, which we could talk for like an hour on. But anyway, I'm going to throw it out to, who's the first one I'm going to think of? Well, I don't have the list in front of me. Who wants to go first? Anybody? Not you, Jerry. No, somebody from industry, please.
I can try to
hop
sort
on
this off.
this, Karl, or Elliot, you can take it.
No, Brant, all you.
Okay. All I was gonna say, from a very high level, I mean, we care about our ROI on it. You know, we've been investing a good amount of IRAD in developing our carbothermal technology, and I don't think we care so much from a what location we're gonna be at standpoint, but we need to know how much oxygen people are gonna buy from us or other metal products, because we're investing X amount of money in this ourselves. And if we can't sell enough to make that ROI lucrative enough for us, it's going to be hard for me to sell it up the chain that we should keep spending money on something like this. And I know that's a total chicken and egg thing, but
Not really. They're asking what you need to know, what will be bought from you.
and
Yeah.
how much, you know, if we really know
exactly.
NASA's going to go there and buy X amount of oxygen, or there's going to be some, you know, cislunar infrastructure up there to refuel satellites or whatever, you know, that would give us a lot of incentive to put something up, invest a lot of money in putting something up there, because we know it'll be there for a while.
So you're asking how much metal, or no, how much of your product, metal-like product, would be bought, and what characteristics do they need to have? And so now this would be a good time for somebody from the demand side to jump in and say, you know, based off of what you guys can make for us, this is what we would be willing to buy from you, or could you make this for us? So Elliot, we're going back to you, but maybe we could have a demand side company or two start speaking.
Well, I'll take that on a little bit, but maybe not too much to your point. You know, our goal in the end, you know, the construction part of it, and the materials, is really a means to an end for us as port operators. Essentially, we want to be the operator of the landing port and do the maintenance and the refueling and the refurbishment of the spacecraft. So that's what we would be selling in terms of the ROI in our construction investments and material investments. The materials that we would end up producing, you know, it could be sold to anybody who wants to build something, wants to build a road or whatever. I think even the extraction of metals that come out of these processes we saw, where we have refined potters that could be exported to an in-space orbiting commercial platform provider, where they're building large arrays, when we insist lunar space and we need to have eyes and ears into deep space for the adversaries. When we need to build things that we can't build, launch, in multiple launches, it's easier to build in space. So those are exportable resources. I think we should start looking at as well, which is down the road. All this is all down the road. Thank you.
Thanks, Sam. Anybody else want to take a stab at answering the question?
Keith has his hands raised. Yeah, go ahead, Keith.
Yeah, so I was just going to say it's Brant made the comment about chicken or the egg. We really need to know what's going to happen there. If you look at any major sort of construction investment, there's always the what that you're building, and the why is because they've secured some sort of some sort of commercial agreement that enables them to get financing to go build this facility, wherever it is and whatever remote location it is, right? And so, if there were several industries that were mentioned earlier in the day. You talk about tourism, you talk about what was just mentioned about servicing and building space vehicles. That those industries have to push the envelope in terms of saying this is what we're going to go do because it makes us money, and then that's going to enable the downstream effect of the construction companies needing to provide resources and come up with plans and come up with designs to facilitate those needs, and then they'll be the ones that are buying from the supply side the raw materials to go and build that. So I think that it's definitely the opportunity, I guess, needs to mature as we see benefits of doing things on the moon. And NASA is going to lead the way in terms of getting us there, but once we're there, how do we expand and how do we scale is going to be dependent on what we can provide that's of value to somebody. And as those things are identified, that's when the scalability happens, right, to support those activities.
Yeah, and if I could add, I think what might be an approach that helps solve some of the chicken and egg problem is if it was sort of a Google Lunar X Prize type approach, to where there's a bounty that gets paid to someone who is the first to demonstrate, generating X amount of whatever resource it is, whether it's oxygen or some other material feedstock. And a bunch of different companies competed against one another to go after that prize. And then as a result of that development going after that one specific bounty, there's a number of companies today that have technologies that have matured to where they're like, CLIPS providers working on landers to actually provide sustained missions to the moon. So, it would allow us, for example, to say, hey, this isn't just a science experiment. There's real money to be had if we can hit our milestones. And if we're successful, then we've taken a TRL bump up to where we've gone beyond the can we do it, how would we do it, to more like, oh, well, the technology was demonstrated in this particular fashion, and now we can start to make more detailed, plans and courses of actions based on now this new concrete level we've reached. And as opposed to like a priori trying to like say, oh, well, we'll buy, exactly this much material at these times, and this is what the demand will be. It's good to like have predictions about that, but I think the core technologies need to get to that demonstration phase first, and a big cash bounty would be an easy way to get commercial investment for it, as opposed to having to kind of do it through a different programmatic approach.
Karl, can I jump in here?
Always.
All right, I'm going to take a right-hand turn, so feel free to interrupt me. I see a issue with our segment, with the resource extraction segment of the space economy. And Mark Hilburger slightly alluded to this, where effectively we see NASA as our sole customer. What are we going to sell to NASA? What is NASA going to buy to us? And based on our own projection, Lunar Resources projections, I don't think NASA is going to be a big customer. And in fact, I don't think NASA is even going to be the biggest customer in the US government. And when you start over the past 6 months, we have seen a major change in interest to develop lunar infrastructure in the private sector, and specifically non-traditional aerospace companies coming to us saying, can you build this asset, or can you build this building? An example is I had a conversation with a very large energy company yesterday asking us to build them a power grid. 2 days before that, on Monday, I had a discussion of making a greenhouse on the moon. And last week I had a discussion of making a landing pad. So I just wanted to throw out there that, as an industry, or as a segment of the space economy, we need to stop focusing on NASA as the sole customer, leverage what they need to implement the infrastructure needed to make Artemis program happen, but also explore the commercial space. Because back to Laurent's point, to me, what makes space or the moon sustainable is having a strong commercial demand for resources and products from the moon, and that's what we should be focused on.
To that note, I have not seen any kind of business plan that actually makes sense that's within 10, 15 years out for commercial utilization of the moon. The only customer that exists is NASA and other government, usually space agencies. There might be some military interest there somewhere, but there doesn't seem to be any commercial thing you can do on the moon to make money in a time frame that investors want to see a return on.
I would strongly disagree with that. There are business cases from power. There are business demands for communications. There's commercial demand for power, commercial demand for communications. There's commercial demand for doing weather, space weather from the moon. We have closed more than 6 business cases alone for large scale infrastructure, and we're not coming up with those business cases. There are people coming to us with those business cases that are saying, hey, is this possible? And how do we make it as cheap as possible? And that's where the in situ metals approach to doing this, that's where we need to come into play. We need to make sure that they can do this economically. Can
you allude more on one of maybe your favorite business case?
Energy. In fact,
and who do you
close our own energy case, right? The resource extraction industry closes its own business case for.
But our customers is NASA.
No, it's not. Okay, so if you, all of us in this room on the supply side require buku amounts of energy to extract anything, right?
Yes. And once we're done with the instruction, who buys our products?
So the people who buy those, so the people who buy those products are a range of customers. I know you want specifics. I'm not going to give them to you right now, but I'm telling you, we need to reach out to commercial partners to actually develop a sustainable presence on the moon and not just rely on NASA.
Yeah, I think what Elliot is talking about is a space-to-space economy. Right now, we're focused on a space-to-Earth economy. And when we start to get to a point where we're selling to each other services in space, that's where we're seeing those business cases come to fruition. Like, we would need to have somebody who would be our partner in providing the comlink. We would be buying their data rates of their data bandwidth, and a power company that would be providing the power system. We would be buying from them to service our operations. So it's a space economy.
I want to follow up on that thread, or maybe orthogonal, the way Elliot went orthogonal as well, which I thought you all had a very important conversation just now, because it shows that maybe NASA is both enabling, and NASA can also be in the way, because it could be a rate limiting step as well. And so at some point NASA needs to move out of the way. Now may or may not be the time for NASA to do so. I think they're very enabling. Absolutely. And so back to that point, what are the specific maybe approaches, or I don't want to say standards necessarily, because standards generally means like we're going to use 40 watts or 50 watts or something like that, but some common agreement that each of the resource providers can come up with, and then the demand side the users come up with, so that you can enable each other. So that think of a radio analogy, that you aren't speaking on different wavelengths and therefore have incompatible radios. Is there an area where we need to already start thinking about developing common ways of doing things, standards? Hey, I'll use that word after all, so that company A and company B and company C that are making different products, at least on the demand side, they can use all three of the products, and you aren't building a different use case for each product. Can you guys start talking about the needs to maybe start standardizing early, getting the rail gauge set now versus waiting to the future and you have 40 different gauges of rail out there, so to speak?
Perhaps I can jump here.
Yeah.
So one of the things we'd like to start an economy on the moon, and we'd like to have trades between companies. So perhaps NASA could fund the standardization of the actual physical movement of material between companies in such a way that we can all receive and send it in something that we can prepare for. So I think, working out the details of the exchange of physical goods on the moon would be a good start.
Interesting. Are you saying, okay, let's say you make a metal, and then another company wants to use it to build something with, and NASA would say, well, we'll provide the service that takes the metal from your metal plant to the construction site, so that the construction people do what they do, and you do what you do. Yeah. And they're just an enabling organization. Standards are going to be really important in that, defining. Yes.
Yeah,
okay,
either standards or providing the service of moving it itself, or providing a company that does the moving of the physical goods. That's just one idea that could help.
Karl, I think that's where NASA, or at least some part of the U.S. government, could take a big lead. Is creating those standards. If for example, if Lunar Resources create the standards, I'm going to create the standards that probably benefits Lunar Resources the most, right? So
I would hope so.
Hey, if you're offering, I'm willing to do it. So with that said, I think that's a great program for NASA to develop, is develop the standards for the purities of the metal, of the form factors of the metal, and the form factors of the metal.
Well, industry would have to weigh in on that. NASA would just arbitrarily make those standards, to Jerry's point,
Yes, but you have to start somewhere.
Yes, but we need to start at an informed direction. And this is where the demand side can inform us.
You see, my background is in propulsion, so I have a fairly good idea in terms of what types of propellants, what quality, what quantity of propellants are needed for different types of applications. I got into ISRU because I was asked to figure out how to fill a Mars ascent vehicle for a sample return mission study. That said, I am not an industrialist. I'm not a manufacturer. So going back to a comment that I think Karl had early on, there is a big question about, how good is good enough? Obviously, trying to have ultra pure silicon for solar arrays or electronics is a big end goal. Having high quality aluminum could be a big end goal. But if we're starting early on, again, how good is good enough? And I've done studies in the past where we worked with the propulsion community and said, okay, if hydrogen and methane wasn't the right fuel, what else could there be? Could I make a kerosene? Could I make, some other hydrocarbon? And we got into this back and forth about, okay, well, if I use that fuel, here's the ISP, this changes my rocket equation, my performance. To some extent, that is a good discussion to have here. I saw some very interesting, things that were being made on Earth and the relativity space, building a whole rocket out of, really good classes of metals. But if we're already on the moon, we don't have to go through a launch cycle and the vibration that is associated with it. Hey, for some of these early things, how much can I get away with without screwing up my additive manufacturing construction technique, for example? And as we go along, yeah, maybe you get higher performance metals or feedstocks, but we got to find that balance. And again, I have a pretty good idea as to the propellant versus the rockets. I think both Mark Hilburger and I are still kind of working on, how much beneficiation, how much processing do we really need to do to get that iron or aluminum or ferrosilicon.
Yeah, you're right, Jerry. I mean, we're really in the beginning stages of doing some of these, I just say, baseline structural sizing. In fact, Athonu and his group are helping me with some of that. As I alluded to earlier, we were doing some initial sizing for tall towers to hang solar arrays, and that's when we found out, well, the stress levels are really, really low in these members. We don't need like a 7 series aluminum. We can get away with something that's, not like a series 1, which basically doesn't have any other alloying components in it. So yeah, it's those types of studies that we need to continue to do, and bring in as much information from these folks to understand what types of materials could we get, and are they good enough? Yeah. Good line of dialogue for sure.
Yes, go ahead.
I was just going to add to this that I go back to the idea of setting some minimum standard. In other words, if there's going to be a metal component that's going to support the roof of a habitat, we need to know that the roof isn't going to collapse. That sets sort of a real low-tech baseline standard. But as competition evolves and different ways of manufacturing evolve, we're going to find out it's really a cost competition. You can put it in terms of how much power it took or how much mass of material and so on and so forth. But if there's a better beam that can do the job and it's available at a lower price, that's going to help drive the standards once we know what the minimum baseline has to be.
Yeah, I can try and draw a parallel between the architecture and engineering world with what we're talking about here. But I mean, we're all sitting in a space or a building right now that is predominantly dictated by rules and regulations governed by, your municipalities or your government. And so I think once we have, some of those baseline requirements from government or some kind of regulatory agency, then as designers, architects, and engineers, we can start to come up with ideas and specifications that make use of specific materials and construction techniques. So if there was like a customer who had, some kind of economic contract to, let's just say, build like a shelter, an exposed shelter for whatever reasons, then they could come to, an architect, engineer, and say, this is the program, this is how much volume and area I need, this is the kind of activity I'm going to perform in here. And then we can come up with the designs and specifications that then we start to like subcontract and find, people who can provide the materials for the construction of that object. That's one way to think about it. Another one would be, just having samples, doing some, performance models that could start to set the performance standards. So if you want to build a landing pad and that landing pad is supposed to support, let's just say like a starship landing on the ground, then you don't want it to crack. You want it to be able to withstand the loads. You need to have a certain depth, maybe reinforce it. Maybe it's tessellated so that it doesn't crack. All these kinds of features can be specified in the concept, the design, and then we can talk to manufacturers and providers who either have those materials or have those means and methods on site already. So I think that's maybe like one thing that is also missing is who is coming up with the concepts, the designs, something that we haven't really talked about. But I open it up to you guys for discussion.
For me, being a layperson, what you showed previously, and it's all triangulated. The interesting structures you can make are a function of the materials and the manufacturing process, which is a function of how do we make those? So I do see that being very cyclic in nature, that the architecture that you consider will drive your manufacturing techniques, which will drive your production techniques. But then if it's not good enough, how does that cycle around? And I think a good example of that is landing pads. So I remember, Kennedy Space Center and the Pisces organization in Hawaii and Honeybee made, very simple landing pad. They built the bricks, they tried interlocking them, they put a solid rocket motor down. And when they lit the solid rocket motor, they quickly saw that the gas got between the pads and it just basically, blew it up to some extent. And so here, you started with one side going, okay, hey, I can make pads, I can do all this stuff. But when you got to the application, it failed miserably. So again, they realized, okay, I got to now put seams in there and do other stuff. And I think, what Mark and I were talking about, I think that there has to be some level of trade, some discussions. Maybe we do this on Earth in 1G. And I see, taking the 3D habitat challenge, for example, one step farther could be an interesting approach. When somebody talked about challenges, I think that might help a little bit more. But I think that's a really good point, that the architecture and what you want to build is critical as well.
What it sounds to me like we need to start doing is start almost like building a characterization catalog of, these are the building blocks that you will have available to you as a designer when you are designing your habitat, designing whatever structure you want. So for example, it sounded like a couple different companies on the demand side were looking for wire feedstock, if I'm not misremembering anything. And we've got the ability to get iron or aluminum. Those sound like some of the most needed or interesting materials. So, maybe we work together, supply side and demand side, to do a manufacturing demonstration where it's like, look, we generate some aluminum wire from our process. The people who are using it for AM run it through their manufacturing process. Material properties can be characterized, and then it's like, okay, well, we can print with this from these representative processes, and then you have a more clear picture when you're establishing standards or establishing minimum requirements, because you could say, oh well, it needs to be 60-61 aluminum strength, but we don't have all the alloying agents available in situ to make it. So what could we do with what we can make, because you have to kind of start from the point of, this is what we have available and is it sufficient?
I would draw another parallel, which is, look at the way that they're developing the Starship. They're just testing, making, and breaking. But I think maybe from the architecture side, we need to start doing that. We find some land in the desert, and then we start to bring those capabilities together and just start building things, testing and proving the concepts, because a lot of the technologies, they're not just material, applications. There's also like equipment, robotics. We have to figure out how to engineer these new pieces of equipment to withstand the environment. So that'll be another capability that needs to evolve. But obviously you need to test it in its proper environment. But I think just a proving ground for having demonstrations like that would be super valuable. And I do know of a few like examples where they've taken technology spinned off from NASA competitions and they're actually applying it to terrestrial applications for development. ICON is one example, but there's others. But I think, yeah, that's very important, just testing things out and leading the way through our own, ways of working together.
I believe a lot of the larger aerospace companies are actually doing a lot of this work as part of IR&D. So I don't think we're starting at ground zero.
Going back to standards, one thing we needs to start with is the standardizing the simulants that we use in here. So we understand that we all have the same information on what kind of simulant is being applied to whatever process. Because not all simulants are the same, and not even every simulant from the same quarry is the same.
Yeah.
I would be a little bit careful about that. I do think simulants and having appropriate simulants are important. I don't believe one simulant fits all because the moon is not homogeneous. So to some extent, I'm a, a, a big proponent of making sure a process can operate with multiple simulants, just because until we go on the moon and we operate with real lunar regolith, there are going to be, aspects that we need to be worried about. So I agree with you, Sam, that making sure people use appropriate simulants. I wouldn't call it necessarily standardized, but
Yeah, I think I'm more talking about quality control. We have a supplier that has a simulant, and from one batch to the next, it's not the same. So that kind of thing is.
Well, that's not a very good business case then.
Yeah.
NASA was in the business of making simulants in the past. I think we're trying to get away from being the producers and repository for simulants, trying to open that up as a business as well. And so that's a good discussion to have with the simulant providers.
Mm-hmm. Yeah. And it'd be good to have a sample return mission of some sort. We have a lot of simulant coming back to work with, not simulant, actual soil. Yeah.
Yeah, just to change track a bit, interesting question from Alex Jail in Q&A. Why not sell repair parts to satellites? And because obviously delta V from moon to Geo is much lower than from Earth to Geo. So just to broaden the horizon here, could lunar base serve as something that can repair, maintain, and sustain cislunar economy? That could be one step towards commercialization or lessening the dependence on NASA. Is it something being thought about?
So I can take that one. The current challenge with doing that is infrastructure for launching, at least having reliable launch back to cislunar, as well as just the standards for manufacturing spacecraft quality parts on the moon. I do see that as a longer term, longer term opportunity, as well as making large structures in space from lunar materials. But I see the immediate market is developing the lunar infrastructure to allow us to do those get into those larger markets, such as satellites.
I have it. Oh, go ahead.
The whole thing reminds me of the beginning of the internet. I remember, while I was young, going on in 91 or something, the HTTP protocol wasn't even made at that time. It was still Gopher. And at the beginning, there was only research centers and universities and such that was connected. And then it was 10 years before it was commercialized at large scale. And I feel that building the initial infrastructure, like Elliot said, will allow for the development of the commercial potential afterward. But the first thing to do is to make the connection between the various basic parts, and it's difficult. It was difficult at that time to make any commercial case, but it was important to lay down the groundwork because it happened by itself later on. So if we have the infrastructure on the moon and power and communication, and we start building the capabilities, it will organically, evolve into commercial cases.
So Karl, going back to what are like the business cases of the moon, I know I kind of sidestepped that question from Geo. One of the core ones that we're seeing right now at Lunar Resources is landing pads. Jerry or Mark, do you know how many CLIPS providers there are right now? I mean, I think there's over 15 companies, correct?
I know there's at least 12 that are on the NASA contract that are viable for putting in proposals.
Right. And that's just US, those are just US providers. I think there's a range of
Yes.
other ones internationally too. So, companies like Lunar Resources, we almost have an infinite demand of landing things on the lunar surface. And so, that is an immediate business case that closes of building these landing pads for these landing companies, and doing it in situ, of course, is the most obvious way to go. So Karl, just try and bring things back to, how do you close business cases?
Okay, thank you. I want to take it in a slightly different direction again. And this is something that's been brought up by both the demand side and the supply side, which is reducing the amount of dependency on astronaut involvement. Everybody says we want to do as much autonomously as possible. And yet that's a bit of a catch-22 because autonomy, the high level autonomy needed to do a lot of the work doesn't exist, low level does. And so I would like y'all's discussions, thoughts on what are the relative roles in the near term, right, for getting this first infrastructure on the moon between robotic autonomy and, please specify whether it's high level autonomy that is unsupervised or it's supervised autonomy. So there's a low level autonomy and therefore there's telerobotics with low level autonomy, or you actually need astronauts there for the development or application or whatever you have in mind for doing on the moon, whether it's building a building or producing materials that buildings can be built from, the metals. Anybody want to take on that question about how are we really going to do that? Because things will need to be repaired. You have to build stuff. No, this isn't just a case of making a brick and then as someone said, anyway, then building a building out of the brick. There's going to be a lot of transportation and manipulation involved there. How are we going to do that?
I would say that, sorry, go ahead.
Go ahead. No, go ahead.
Oh, thank you. Just based on research projects that we've done and been a part of, you always need to have some human element involved because, current state of the art, even for robotic fabrication or manufacturing remotely, it's not to that level yet. There's always like servicing the equipment, something always goes wrong. You're processing in a very extreme environment and, something is bound to need a mechanic on site to fix things no matter what. So there's going to be a lot of, I think, like progress to be made around going full autonomy. Like that's going to take some time. And then the other thing is, I would say that the, like elements like landing pads are, I think, the low hanging fruit. Larger structures like cylinders or shells or anything else that like contains a large amount of volume, that's going to be way far into the future. We're not there even on terrestrial terms yet. I think that's going to be something that we need to develop first, here on Earth before we can even think about doing it remotely on a different terrestrial body.
And I think it has a lot to do with the cost of labor. See, here on Earth, it's pretty inexpensive to hire somebody. On the moon is quite different. And then there's also the risk that the astronaut takes and how much the risk of the funding agency is willing to, how much risk the funding agency will allow the laborer on the moon to take. So, labor and astronauts are going to be a very, very scarce resource. And then the same cost optimization has to be done for autonomy, and that just probably means that simpler systems are better. Low hanging fruit is the way to go. And if you have a machine with 1 million parts, it's very expensive to make it work reliably.
Yeah, I think even in the demonstration by relativity, you see that there's a lot of automation happening, but I am pretty certain that you have people monitoring and making sure that that machine doesn't break down. And they're maybe stopping it at certain points, but there's a lot of overseeing that has to take place.
Yeah, and I would, I guess, echo all those comments. I think that we should plan for autonomy to the greatest degree possible and plan for that to work. But I think that telerobotic repairs or maintenance is important. In fact, we're supporting a group from the Space Resources Department at Mines to use our iron oxide reduction automated rig as kind of a demonstration platform from which they can develop robotic repair techniques. But beyond that, having had some terrestrial industrial experience, I've often found that the plant operator who carries the mallet and he knows exactly where to hit the pipe and how hard to get the material flowing is one of the key personnel. And I think we don't want to rely on that, but I think you've got to recognize some realities and do the best we can on automation, but plan for hopefully robotic repairs, but in more sophisticated systems. I think astronauts can be a real big player in this.
So what you're saying is that in every ConOp, we should have a redundancy built into the system, right?
Well, I think that's always good, but there's a practical limit in terms of mass and
Cost.
Sophistication, but that's always a good plan. I agree.
And redundancy only gets you square root of 2 in reliability anyway. So it's often a trade-off with redundancy.
Hey, I want to poke on two things that kind of came up. One is when we, again, looking at the water oxygen mining pathway, it's always been, kind of a progression. And, with the charts that Mark and I presented earlier, we have an envisioned future of all these wonderful things happening. But, I've learned early on, you have to take reasonable steps periodically to get you to that envisioned future. So, we talk about demos to pilot plants to eventually some kind of a full-scale plant that makes tens to hundreds of metric tons of product. So I could see the same thing here. And so I want to poke on two questions to both the supply and demand side. One is that idea of setting up a location where both sides can start playing, building things, trying new materials that other people have created, trying manufacturing techniques with materials, whatever the case may be. The other is recognizing delivering mass to the moon is still expensive. What are those basic building blocks? What are those basic tests, whether it's a manufacturing technique or robotic or whatever the case may be, that the community sees as being important to push this all going forward? So sorry to hijack your meeting there, Karl.
It's your meeting, Jerry, and it's the supply and demand side meeting. I'm here just to enable you guys to come together and talk. I think you brought up a really good point. You said, why don't we set up a lunar playground where we can test, fail, and test again and bring all the sides together so we can quickly iterate to a workable solution. I think that's what you said. I think
yeah, that was one part. Is that something the community could get behind? And the other is, if we're going to push, we recognize, we got a chicken and the egg problem here. How do we push that, both sides of that story, both on the ground as well as with small demonstrations leading to bigger demonstrations, leading to whatever the case may be?
Jerry, do you think it's defining, like, what's the one thing we want to go do right in that sandbox? Is it build a power plant? Is it build a processing facility? What is it, a landing pad? What do we want to go build, right? I feel like if we got behind one of those things, we could decide, hey, we're going to go build a power facility, and these are all of the components that we need, and these are the specifications that we're going to use, and this is the first go at it, and we're going to, obviously these documents are going to be green, and we're going to agree that things might not work out, and we're going to iterate on those things. But I think that if there's that one thing that we can go as a group and say, this is what we're going to go do, that would kickstart.
I think there's multiple playgrounds, to be honest.
Yeah, agree. Yeah, that's right. Yeah.
I think, different communities might wrap around different aspects. So I do see a power infrastructure. Okay, how do we build arrays and cables for power generation and storage and transfer? That could be one thread, one playground. How do we build landing pads? How do we make sure that we have, facilities that we can set up for reusable transportation and hoppers and, landers or whatnot? That could be another playground. I think the construction playground, especially for if I'm going to put a human inside a structure I built on the moon, that layers a whole bunch of quality control and safety features, which will drive a large number of activities. So that could be another stream of how do I eventually make a pressurized building, So I'm opening it up. I don't think we should constrain ourselves to any one. If we follow multiple pathways, just like we're following the water path and the oxygen path, there could be these separate paths, and you follow them as it logically makes sense.
Yeah, and I agree with that for sure. And I think it's difficult right now. It's been difficult for my team because we don't yet have a solid understanding of what even an initial infrastructure we need and how it's going to grow. So we've been sort of forced to take these parallel paths and make some assumptions on what the design requirements are. And that tells us maybe what sort of materials we need, what sort of construction processes we might consider, and start talking about, which ones are more amenable to autonomy, which ones are not, and so that's another case by case type of thing. But really to have an opportunity to do some of the more complicated integration tasks like outfitting, which was brought up earlier today, man, we sure want to do everything we can on Earth that's going to be complicated. You just got to be there to do it the first dozen times right on Earth before you can even think about being able to do that on the lunar surface. So I think, this idea of having a lunar playground or multiple, I think is fantastic. And something for sure that might be a real catalyst for bringing everybody together and partnering.
Yeah, I really like Jerry's idea about a playground because, back to the automation question, if we were to deploy infrastructure on the moon, we didn't want astronauts to have to run around and do a bunch of things. Like one of the things we would need, or any of the other processes, would be someone to supply us with Regolith. I know there's different rover companies out there, people working on different autonomous, vehicles for doing stuff. But if there was a playground where we could demonstrate automated loading of Regolith in sort of a simulated environment into a process, and then have an output, and then, I don't know, have the rover go bring the little tank of process gas over somewhere else. I mean, being able to work out all the kinks on Earth, and that really helps an awful lot. And, you can do it in small sections, and then as each of these sort of independent islands of power and process and construction and so on get developed, you could then do more ambitious integrated demonstrations as each one of these technologies comes together. And, I don't know exactly who pays for all that, but especially if, like, we could say there's a lunar playground where when we go to the playground, we can demonstrate these key milestones, and they're valuable milestones that stakeholders care about. That's a very convincing story to say, hey, the technology's reached a new phase, as opposed to, oh yeah, we're, playing around with stuff.
Probably shouldn't call it a playground though, right?
I don't know. I thought it sounded right to me, but
I'm just kidding. We have to be sensitive about what the taxpayers are thinking of what we're doing, right? So
no, but I think what's great about this idea is that as soon as you prove it somewhere on Earth, you immediately can find a customer who's looking for that kind of innovation, whether it's in the residential development side or commercial development, or even just mining and construction in general. I think you'll find a customer on Earth and it can sustain itself. So the technologies have to evolve here for us to be able to continue to think about implementation and future purpose. But I would suggest that the playground is something where innovations take place to get us, where we want to go. But along the way, we're capitalizing on these technologies and innovations on Earth and making things better here.
Yeah, Rob Mueller brought up proving ground, which I think is much more sellable.
Yeah.
The other thing is, when we used to run field tests in Hawaii every 2 years, and the second one probably was the most interesting because we had multiple countries and multiple small businesses provide the hardware. And NASA and CSA basically did the job of kind of the systems engineering, making sure that all the players knew who each other was. And not all the interfaces were perfect. The water or the fuel cell made water. We captured it in a bucket, carried it over to somebody else, poured the water into it. But that whole process started to show the end-to-end applicability, as well as where the gaps were in the interfaces. Oh, this one was using DC power of a certain type. This one was using AC. How do we start standardizing that? So here again, I think this concept of is possible. I don't know, the right mechanism to bring it forward, but and it will require some level of reasonable openness between companies to make sure that information is passed. What's the purity of your metal and the form and the hardness versus the manufacturing technique? What does it need? But it does sound like it's doable. I still want to understand, where does maybe CLIPS missions and lunar missions help move this ball forward as well? Or is that just an outgrowth of what the proving ground tells us we should work on?
I'll just throw an idea out there, but perhaps it's like a lunar innovation center where we could go and we can lease out a certain area, space, facility, and then there's expertise on site, equipment that you can also make part of your lease, and you can tap into that expertise and just build stuff. And hopefully the funding can be, come from multiple parties, could come from the commercial side, it could come from government investment. But if you were able to prove at least a simple innovation or something that improves one technology, then that becomes, the spin-off. And that might be something worth thinking about. And I know that there's some universities doing that as well, which I think could be pretty cool for us to be a part of if we had that available.
Anything else?
I was just looking at the clock saying, wow, guys, it's 4:30.
Already.
But I just want to say that lunar proving grounds, that's one theme that's come out of here, that there's a lot of takeaways we've had. And we should probably have our wrap up now. And I think as a wrap up, I don't know if if everybody's tired, if you guys want to go through and give one last thought on your mind about this next step forward, that might actually be useful. Should we develop a lunar proving grounds, maybe with a lunar innovation center in it, discuss things such as defining what is good enough so that we could determine what it is that what technologies we're actually proving and what they need to do. And we've made a lot of progress today. I think we've accomplished what we needed to in the first step. And we need to find a way to maintain this momentum and follow up on what we've done today and not let it go by the wayside and say, oh, great meeting. And then we write a report and it goes away. And the onus is on Athonu and I, more on Athonu than I, right? Anyway, the onus is on us to do that.
Yeah, and also the lunar proving ground, then there are many issues and that will come up eventually as we start talking about it. Like,
Yeah.
who owns the rights to the technology that comes out
Sure,
of it?
sure.
So many things, but
Karl, one thing I'd like to say, just piggybacking off of Jerry's comments.
Yep.
In my mind, Jerry said maybe clips after lunar proving ground, but in my mind, it would go the other way because we're fast approaching a point where the risks we have in our system, we need lunar gravity or the real regolith to reduce, to put those to bed. And if we go straight to a lunar proving ground, we may just find out right away that several things we thought didn't actually work. We need a technology demonstration mission first.
That's kind of why I was poking on that, Brant, was, at what each just like the water path and the oxygen path have different pacing items. The supply side and the demand side for this activity will have pacing items, and I want to make sure that they're not lost. And if something critical has to be done on the moon to make sure you're steering in the right direction, I want to make sure this community recognizes that early. So I agree.
Agreed. But I like the lunar proving grounds because it will intrinsically enable system engineering. Well, one thing that APL role is, and that we often have a perspective on, is like we need to have a system approach to anything we do. And I think the architects have even more of that. That's a system of systems. And I think the lunar proving grounds could potentially allow us to quickly define, develop, and test these systems and system of systems so that we can implement that technology as infrastructure on the moon more effectively, more quickly. Of course, you got some tech you need to test under lunar gravity, of course, right? Yeah, you have to do that. Yeah, what is it, Elliot?
Karl, I just had one thought. Back in 2018, 2019, NASA did a LEO-COM study, a LEO commercialization study. And it'd be interesting if NASA could do something similar for lunar surface business cases.
So I'll just throw this out there. Here in San Antonio, we're actually looking just at doing that proving ground. I don't know if the scale you're talking about, but we got to go ahead to try and put together the programming for a large facility at Port San Antonio, and it'll have a partner in the University of Texas at San Antonio, in the Port of San Antonio. So we're at the point of doing the programming for that. What are the requirements? What are they going to be? What's going to be the research aspects of it? And I invite anybody to just email me if you have certain requirements that you think you would like to see in this kind of a building. And we're on that path, actually. So I don't know if you're talking about this would be a kind of quasi-private type of arrangement. Thank you.
Thank you.
This will be a public-private partnership.
Good. Okay, so Athonu, we're going to be on the hook to write up a report for this meeting, and we'll try to get that out quickly. And one thing that could have come from this, I saw a few texts about this, is a follow-up meeting about some of these themes. So any comments from the provider, supply side, demand side, or NASA about if we were to do a follow-up? And one of them was, McDonald brought this up, we should have power and EC and ISRU together, because it's really a tripod. You really have a triad. You really have to have all three in order to have a sustained presence. Any thoughts on the best way to afford a follow-up from this meeting to the next meeting? Where should we evolve to?
Well, one of the notes that I took down, it was really to myself, but I'll say it here, is that it sounds like we need to have more conversation on, with industry on, where they see commercialization happening and what are the basic pieces of infrastructure that NASA needs to help, you know, provide the capabilities for. And I think I rely a lot on Mark McDonald and his vision to help me in my planning. And so I don't want to put him on the spot without him being here, but I think that we probably have to have more conversation on, you know, the business case and what is sort of the starting point for the infrastructure, and then the evolution of that infrastructure, so that we can start to have that iteration of ideas. That was, I don't know if that would be a good topic or not, but that was the thing that popped into my head was, you know, trying to have more conversation about where we want to go with starting and the evolution of the infrastructure to support commercial.
Thanks. More thoughts, guys?
Elliot,
Everybody?
Elliot has
Yeah, I mean, this workshop was Regolith Rebar. And I think, you know, as Mark just said, you know, there clearly is a gap between the demand for of raw materials to demand for infrastructure. So I think a next workshop could be, you know, rebar to infrastructure, something along those lines.
So rebars to roadways, how's that?
Yeah, there you go.
Okay. More thoughts, guys?
closing thoughts.
Closing thoughts. Yeah, it's getting pretty late, really is. We're all getting tired. It's 20 till 5 our time. So yeah, last closing thoughts from everybody. If you want to say anything, go ahead. And then we'll just kind of call it a day, and we'll follow up with a report later.
Yeah, I just wanted to thank all the presenters. I really enjoyed it, learned a lot for sure. And like you were saying, I think this is a really good first step. I'm really excited for us to very soon have sort of our larger vision available for everybody to see, as Mark McDonald was saying earlier on. So yeah, expect to see our envision future priority packages. I think Jerry's and mine will come out around the June timeframe, but gets into a lot.
We might have a smaller sneak peek at the LSIC spring meeting.
Yeah, that would be great. Yeah. So I just want to say thank you to everybody.
Yeah, same here. Good conversation. It's really tough pushing both sides simultaneously. I definitely appreciated the conversation and the information. I knew a lot about the metal side, not as much on the manufacturing side, so that helped out quite a bit. And I do greatly appreciate the openness of the conversations between all the speakers, taking the you know, how do we really move this ball forward? Something that many of us have envisioned for a long period of time, and quite frankly, didn't think we would get this far. But I am optimistic.
Yeah, and it was a pleasure to speak with all of you, you know, from fellow companies working on the supply side to, you know, everyone on the demand side and NASA and in between. And Daniel had a good point about contact information. Is there going to be like contact information just available from the presenters, or should we like reach out individually to all the different people to try to like work things out? So we would like to have some follow-up talks with people here to see if we can keep the ball rolling on a few items.
We didn't want to impose upon you and assume you wanted your contact information out there. So feel free to put it in chat, but we can also put your contact information on the Confluence website and people can just download it. Any other ideas, Athonu?
Yeah, I think Andrea is the best person to comment. Is it okay to put contract information on Confluence, Andrea? Or
Yes, if people are comfortable doing that, you are welcome to do so.
Yeah, you can
and-
add my email to my contact information for the agenda, for example.
Thank you very much.
The one
Oh.
solution could be, yeah, we'll just do it on Confluence. That way there's no pressure. And send me or send Andrea or send Athonu your contact information if you want us to put it on Confluence. And for those
Yeah.
attendees who don't have access to
Confluence.
Hmm?
You should be on the who's who in Confluence. I know I am.
Oh yeah, we only
that's a good
but-
point.
that's true. That's true.
That's a good
But
point.
you know, it also, if you want to contact these folks and you're not a member of LSIC, become a member of LSIC and join the Confluence thing, and you'll get access.
There you
to it.
go. You get
The
special
penalty.
attention and
That's
privileges.
right.
Yeah, I think who's who is the best place. I think that's the best place to.
Yeah. Okay, but yes, contact information be made available if the presenters want to give it to us.
Mhm.
Any
When
more
does-
comments?
Yeah,
Rob?
final thoughts on my end. So I think it's amazing what's going on right now from the supply side and demand side, as you see various technologies being very rapidly developed. And on the news, it seems like every week a new company is getting developing a system or getting a launch contract to land another piece of hardware on the moon. So I am really excited to see what happens over the next 5 years for this industry. And I expect things will be ramping up very quickly to begin large scale industrialization on the moon.
In a responsible fashion. There are some comments about that as well. Yes. Somebody's hand is up.
Oh, that's Elliot.
No. Okay, then.
Let's call it a day.
Yeah, thank you, everybody. It's been a great
Thank
meeting.
you. It was a
Thank you.
pleasure.
It's been
Thanks a lot.
fantastic. Have a good day. Bye-bye.
Great
Bye.
job, guys.
Thank you all.